Hey there, awesome physics students. Let's talk about Coulomb's law of electricity. Coulomb's law is the force law that tells us what the attractive or repulsive force will be between 2 point charges. So here's the scenario. You have a tiny charge here, and I'm going to call that one Q1, and this other tiny charge, and I'm going to call that Q2. Now, it's traditional in physics to call the charges by Q with the letter Q. Q is actually a variable that tells you how much charge that contains. So Q1 may be something like positive 2 coulombs, and Q2 may be something like negative 6 coulombs, so it may be a positive or negative number, but this is the amount of charge in coulombs that those charges have. These two are going to be separated with a distance r. So r is not a radius, r is a distance between the 2 point charges. So Coulomb's law tells us that the force between these 2 point charges will be some constant k, which I'll give you in a second. It's just a proportionality constant. And it will depend on the product of the two charges, Q1 times Q2, and then I divide that by the distance between them squared. This distance between them squared term is probably the most important part of this equation here. This tells you that as you increase the distance, r will increase, this fraction then will decrease, and the force between them will decrease. And specifically, if I double r, then the whole thing will decrease by a factor of 4. If I triple r, the whole thing will decrease by a factor of 9. So it really changes dramatically as you increase with distance. The constant of proportionality here is k is 8.99 times 10 to the 9th, and that's going to have units of newtons meters squared per coulomb squared. Now, there's another formulation of this that's also very popular that you may see from time to time, and that's given like this. So you can basically, it's just a repackaging of the constants here. So it's 1 over 4 pi epsilon naught Q1 Q2 over r squared. So this part remains the same. It's just that k is equal to 1 over 4 pi epsilon naught. Epsilon naught is sometimes called the permittivity of free space. That's a different constant. It's 8.85 times 10 to the minus 12, and that's going to be in coulombs squared per Newton meter squared. So k is related to this 1 over 4 pi epsilon naught, or epsilon naught can be computed from k. It's just 1 over 4 pi k. Okay, it's just a repackaging of the constant of proportionality. So don't be confused by that. Now, remember that the fact that the force depends on the distance here, it tells you how a neutral molecule but polar molecule like water will be attracted to an ion, perhaps. So because this negative charge is closer to the positive ion, the negative part of the polar molecule will feel an attractive force, and that attractive force will be bigger than the repulsive force that this positive charge will feel because of this r squared term, right? The other interesting aspect of this is that this is often, you can use this formula to understand how it feels to touch things, right? So when you touch something, what's actually happening is that let's say you touch a table. The table is made of atoms, and it has negative charges all around it because the electrons are on the outside of atoms. And then your hand also has atoms, and there's negative charges on the outside of the atoms. And as you get these two atoms, the atoms in your hand versus the atoms in the table, as they come close to each other, the electrons will repel. And as you get them closer and closer, that repulsive force increases and increases. And so that's responsible for what we call the normal force. And in fact, most forces that we've encountered so far, the normal force, tension, friction, all of these are ultimately because of the electric force that can be explained. Some of their behavior can be explained like just by looking at this equation.